Hello, boys and girls. It's Miss Evans again with another mini lesson, and today is Tuesday, September the 8th, 2020. Our AKS for this week is NBT.1 and NBT.2 over decimals. Your learning target is I can explain the value of each digit as 10 times the value of the digit to its right. This would include decimals. I can explain the value of each digit as 1/10 of the value of the digit to its left, including decimals. Recall from 4th grade when you studied the relationships of digits. Students demonstrate a digit's value as dependent upon its place in the number. The value of the digit 8 in 328 is different from the value of the 8 in 382. Using base 10 blocks, a student created a model for 328, which is demonstrated in Model A on the left, and 382, demonstrated in Model B on the right. Recall that moving from right to left means that a student will be increasing in value, or they're going to increase times 10. Therefore, you're going to be multiplying by 10 or powers of 10. You can also recall that moving from left to right means you're decreasing in value. Therefore, you're going to decrease times 10, decrease by powers of 10, or divide by 10, or divide by 1/10. Do you remember this activating strategy from today? Where the flat represents one whole, or the ones place, a rod represents a tenths place, and what does the unit represent now? Correct, the hundredths place. It takes 100 units to make one whole. It takes 10 rods to make one whole. Therefore, as we move from right to left, we are increasing by tens. When we move from left to right, we are decreasing times 10. Let's compare the value of the digit using place values. Again, we want to extend our learning now into decimals. Students are going to use the base 10 model blocks to represent 0.8. See the model on the left below. And 0.08 with the model on the right below. How does the value of the 8 in 0.8 compare to the value of the 8 in 0.8? Pause the video to see if you get the same comparison that Ms. Evans gets. Correct. 0.08 times 10 is equal to 0.8. Therefore, 0.08 is 10 times less than 0.8. Or you can say 0.8 is 10 times greater than, or 10 times more than 0.08. Let's look at this place value chart. As you can see, the 8 and the hundredths place moved from right to left, and it increased times 10, leaving us with the decimal of 0.8. The same is true when we are moving from left to right. Right to left. When you have 0.8 and it moves one space to the right, we are decreasing by 10, or decreasing in value. Therefore, we divide by 10. That will give us 0.08. So here we started off with 0.8. When we shifted over to the right, our 8 in the hundredths place decreased by a power of 10. Now, let's see about using decimals to extend our learning with decimals and place value. Here's our example. A student is going to model 2.0 and 0.2. Let's pause the video to see how this is done. The value of the 2 in 2.0 is 10 times greater than the value of the 2 in 0.2, since it would take 10 times as many blocks or rods to create the 2.0. So the way we will write this expression is that in order to move from a greater place value or from left to right, we're going to decrease in value by 10, which equals our 0.2. Whenever we want to move from a least great place value and gain value, we're going to multiply times 10, which equals 2.0. So again, boys and girls, when we're going from a least place value to a greater place value, we're going to be increasing times 10. When we're going from a greater place value and losing value to a least place value, we are decreasing by 10 or powers of 10, or we are decreasing by dividing by 10 or dividing by the 1/10. Okay, so now we have moved from our base 10 blocks to our place value chart. Here we are given the 2.0. The 2 is in the ones place. When I shift over and put the 2 in the tens place, I have decreased by 1 power of 10 or divided by 2. Therefore, this 2.0 is 10 times greater than the 0.2. When I move from a least place value, or where the 2 is in the tens place, and I shift or move one place value to the left, I am gaining value. Therefore, I will multiply times 10. So students, remember, when you are moving from right to left, you are dividing by 10 or a tenth. When you are moving from right to left, you are multiplying by 10 or gaining a power of 10. Okay, boys and girls, so please remember, when we move from left to right, we decrease in value. Therefore, the place value to the right is 10 times less, or 1/10 less than the place value to the left. So we are dividing by 10. When you move from right to left, we increase in value. Therefore, the place value to the left is 10 times more than the place value to the right. That means we are multiplying by 10 or powers of 10. Thank you for watching this mini lesson on decimals. See you all tomorrow. Happy learning.